All right, well, good morning, Green Wave. Today we're going to be talking about double replacement reactions and how you can predict whether or not a product will form. So yesterday in the simulation, you saw that a double replacement reaction is a reaction where a metal and a nonmetal switch places in the course of a chemical reaction. All right, so in this example on the top, silver nitrate reacts with sodium chloride to make sodium nitrate and silver chloride. All right, we're simply switching the metal and the nonmetal with the metal and the nonmetal of the other substance. So in order to know whether or not the reaction works, what we have to establish is whether or not a solid forms. Okay, so the way to do that is simply using a solubility table. Now I have provided a solubility table on Microsoft Teams to make it very easy to look this up. All right, so sodium nitrate, we look on this table. Here's sodium. We go down to the nitrate row, which was cut off, so let me fix that. Here we go, give you a better view. We go from sodium down to nitrate. It is soluble. So we're not going to put S, we're going to put AQ. AQ means soluble, S means solid. All right, now we next need to look up silver chloride. So here's silver, there's chloride, it's insoluble. So we're going to put an S. So the reaction between silver nitrate and sodium chloride will produce a solid, so it is a successful reaction. Now let's look at this next example below. Potassium sulfate and lithium fluoride. We'll make lithium sulfate, so let's look up lithium sulfate. Lithium sulfate is soluble, okay? And potassium fluoride. Let's look up potassium fluoride. Potassium fluoride is soluble. Because both products are aqueous, the correct answer for this kind of question is going to be no reaction. There is no reaction because no solid forms. So that is, in a nutshell, how you do double replacement reactions. Now, if you are asked how to write complete and net ionic equations for a double replacement reaction, let's take a moment and do that. So you would only do this for a reaction that works. So in this case, the complete ionic equation for this reaction is going to look something like this. So every ion will dissociate. So that's Ag plus aqueous plus the nitrate ion, aqueous, plus the sodium ion, aqueous, plus the chloride ion, aqueous, will react. And let's just take a moment to fix the formatting. Obviously these are all charges, so they need to be superscript, and the number of atoms should be subscript. And these react to make AgCl, which is solid. We do not dissociate that because it is a solid. If it disassociated, it would dissolve in the water. It doesn't disassociate, so it's a solid, so it is not represented as a set of ions in the complete ionic equation, plus the sodium plus ion plus the nitrate ion, NO3 minus aqueous. All right, once more, let's correct the charges, make these superscripts. I gotta say, I like this so much better in college. It was like a menu you had to click through on Microsoft Word. It was terrible. You guys kind of got it lucky with chemistry. If you ever have to use Word to write lab reports like in college. So that is the complete ionic equation. The net ionic equation is the complete ionic equation, but we get rid of all the spectator ions. So let's just do a quick copy and paste. And then we're going to erase anything that is a spectator ion, which is to say anything that does not change in the reaction. So looking at this example, we see that nitrate does not change. It is a spectator ion, so we get rid of it. And sodium does not change. It remains aqueous. So our net ionic equation looks like this. You might notice the difference between single and double replacement reactions is that in the net ionic equation for a single replacement reaction, you had two metals. In the net ionic equation for a double replacement reaction, you're going to have a metal and a nonmetal because they're going to react to form a solid. So that is how you do double replacement reactions. It's really No more complicated than that. All you have to do is look at the table, and it's important to write the correct formulas. So how did I get things like Li2SO4? Well, lithium is +1. I know that because it's in the first row of the periodic table. Okay, and sulfate is SO4 2-. It's a polyatomic ion. It's something we had talked about before. You have the list of polyatomic ions that I had passed out in class, and I will also put that up on Teams so you're able to see the polyatomic ions too. So that is how you do the complete ionic equation, the net ionic equation, and the top one is called a molecular equation for double replacement reactions. And as always, if you have any questions, please reach out to me.